Okay, so this is day 2a, and our learning target here is I can identify an ellipse from its equation given in standard form and expanded form. I can graph an ellipse and label the center, vertices, and foci. I can identify the major and minor axes, and I can transfer equation forms algebraically. So on this guy, general form, now this is a general form if it's centered at the origin and it's wider than it is long. Okay, so that's kind of the difference between these guys. So what I want to do is if it's wider, so we'll call that a horizontal. It'll be x minus h squared over a squared plus y minus k squared over b squared equals 1. It's always equal to 1. Where a is always the bigger number. Okay, so a is always the bigger number of the two that we're going to show you. Where actually a is the major axis. Okay, or I should say it's the distance. Where or the major axis is this whole thing right here. Let's just say 2a equals the major axis. So a is the distance from the center to the outside. So this is a. Notice it says 0, 0, a, 0. So a is how far to the right you go and how far to the left you go. B is how far up you go and how far down you go. So it's b and negative b here. Now if it's a vertical one, which means looks more like this, it's going to be x minus h squared, and it's going to be b squared, the smaller. This one's going to be the smaller of the two. Okay, so plus y minus k squared over a squared equals 1. Or the minor axis then is going to be 2b. So whichever number is smaller tells you how far, and how far out in this case. Well, if it's a vertical one, it'd be a would be up and down, b would be left and right. If it's a horizontal one, a is left and right, b is up and down. So you can tell pretty quick if the bigger number is with x, it's horizontal. If the bigger number is with y, a is the bigger number. If it's with y, it's going to be a vertical one. Okay. Now the foci, so this is a focus right here. That's a focus. Together they're foci. And what an ellipse actually is, I didn't put it on here. I should have, because I never pasted that on there. Is if I pick any point on here, and I add together the distance from the two foci, it's all the same. So this distance plus this distance is constant for any point that you choose. Okay, so if I choose a point down here, this distance plus this distance equals that plus that. It's going to be the same no matter what. Or if you pick a point over here, this distance plus that distance is the same as the other two I described. So the C has this relationship right here. If you know the A and the B, A squared minus B squared, and if you square a root, you'll get C. That'll tell you how far away the foci are from center. Okay, so you notice here's a center 0, 0. This would be right C units, that'd be left C units. Okay, so if you find your A, B, and C and your center, you can do a lot. You can pretty much graph just about anything. So this first guy here, first off, just reading it, it's centered at the origin because x minus nothing and y minus nothing. So the center, it says what's the center, is 0, 0. Now, will it be a horizontal or a vertical one? Well, the bigger number is with y, so it's going to be a vertical one. It's going to look like this when we're done graphing. It's going to be taller than it is wide. If we can find the A, the B, and the C, that's going to tell us a ton of information. Well, A is always, well, A squared is the bigger number, so this is A squared, that means A is 3. That's B squared, so B is 2. If I want to find C, I got to take A squared minus B squared and square root. It's going to be a square root of 3 squared minus 2 squared, which is radical 5. Radical 5. If I want to graph this too, it might be easier to start graphing it and then label some of the points. So here's the center, 0, 0. This is telling me since it's a vertical one and that's 3, and that's 9, I'm going to go up and down 3 units. So 1, 2, 3, 1, 2, 3. Those are the vertices. The vertices are the longer way. So vertices, and we actually call these the co-vertices going the other way. So the vertices here would be 0, 3, and 0, -3. If this is a 2, 2 is with x, I'm going to go left and right 2 units, so right 2 units, left 2 units. So the co-vertices would be -2, 0, and 2, 0. And then the foci, yeah, I went to foci last. So the foci, if it goes this way, now the foci are going to be along the major axis. So major axis, minor axis, major axis. So from here I'm going to go up radical 5 units, which is actually up here somewhere. And I'm going to go down radical 5 units. So notice, since it's a vertical one, their coordinate's going to start with 0 and 0. Okay, so they have the same x as the center. This would be, I'm going to go up radical 5, and I'm going to go down radical 5. So it'd be 0, radical 5, and I go down negative radical 5. Okay, so that'd be the graph of it. There would be my answers for those. Okay, flip this over. Again, this is kind of just all the stuff we just said. Okay, so the major axis, minor axis, all that good stuff. So if it helps you look back at this, go ahead. I'm gonna keep going with the notes though. So I'm recording on a loaner computer, and I don't know if I allowed more than 15 minutes for my video. So this guy here, the center is at 3, -2. 1, 2, 3, -2. So there's the center. I can see that the bigger number is with the x, so it's going to be a horizontal one. It's going to be that way. My A is 5. My B is 4. If I want to find the C, it's going to be the square root of 5 squared minus 4 squared. And this one is 3. 25 minus 16 is 9 squared. That's 3. So if I need to start labeling things here, well, I can do, let's do the vertex first. Vertices. So the vertices are, I'm going to go right and left 5 units. That's a bigger number, so I'm going to right 5, 1, 2, 3, 4, 5, and left 5, 5. That would be -2, -2. And it's going to be, right, so 3 plus 5 is 8, and down 2. Notice they have the same y coordinate as the horizontal axis, or a horizontal ellipse. So they have the same y coordinate as the center. Now the foci are going to be on that same line, foci, but they're going to end in -2. They'll have the same y coordinate. Now I'm going to take 3, and I'm going to go right 3 units, that'd be 6, and I'm going to go left 3 units, which would be 0. From here, go right 3 units, left 3 units, there's my foci. And your co-vertices, go to the center, I'm going to go up and down 4 units, so 1, 2, 3, 4, 1, 3, 4. There's my co-vertices there. They're going to have the same x coordinate as your center. So it'll be 3, something, 3, something. Again, -2, I'm going to go up 3 and down 3 from there. I'm sorry, up 4 and down 4 from there. So that'd be 2 and -6. Okay, and then just fill that in best you can. Something like that. Standard form. So here is an ellipse in standard form. I want to, I'm sorry, it's in standard form for a conic section. I want to get in standard form for an ellipse. So it's kind of the same thing as with parabolas. I want to separate, but I don't want to put them on opposite sides on this one, because the x squares and y squares are on the same side together on this one. With parabolas are separated, but with this standard form they're on the same side. But I want to line them up. So 25x squared minus 200x, leave a space, plus 9y squared plus 18y. And now the constant, go ahead and take the other side. I'll bring that over as a -184. Now I can try to complete the square, but completing the square is extremely difficult when that's not a 1. We want these numbers to be 1s. So I'm going to do this. I'm going to do 25x squared minus, and then 200 divided by 25 be 8. Leave a space, plus 9y squared plus 2y leave a space, and that equals negative 184. So I'm going to complete the square inside parentheses. Okay, so what number do I want to be there? Well, it's always half of this number squared. So half of negative 8 is negative 4, squared is 16. So I'm going to add 16. But notice on this side, I didn't just add 16. It's being multiplied by 25. I actually just added 400 to the left side of the equation. I added 16 times 25 over here. So we add 400 to this side. Over here, the number I want is half of 2 squared. Half of 2 is 1. 1 squared is 1. But I actually just added 9 because everything inside the parentheses is being multiplied by 9. So I have to add 9 to this side. Okay, so this would be 25. I want to put the binomial squared. This would be x minus 4, be y plus 1. Then a equals, when I put that in the calculator, 225. And standard form always has a 1 on the right side. But to make that a 1, I got to divide by 225. So I got to divide everything by 225. On this side, I got a 1. Here, the 9 and the 225 would reduce to 1 and 25. So it would be y plus 1 squared over 25. And then this one would be x minus 4 squared, and that would reduce to 9. Okay, so now it is 1 and 9, 1 and 5. So graph that now. So I'm going a little bit faster here. It is centered at 4, negative 1. 4, negative 1 is the center. It is a vertical. The bigger numbers with y, so it's going to be a vertical one. That means I'm going to go up and down 5 units from there. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I'm going to go left and right 3. That's 9, so 3. So 1, 2, 3, 1, 2, 3. Fill that in. Now the foci here, if I want to find the foci, here's a squared, there's b squared. So I do the square root of 25 minus 9 equals c, which is 4. So from here, I'm going to go up 4, 1, 2, 3, 4, down 4, 1, 2, 3, 4. There's my foci. I didn't label them all. I didn't say to label them all. I'm trying to save time, but we could go through and label all those coordinates if you had to. Now, from characteristics. So from characteristics, my major axis, if it helps to do a sketch, if I go, here, so I go left 6, up 2, point left 6, down 8, here's negative 8. There's the major axis, and then the minor axis is negative 3, negative 3, negative 9, negative 3. There's just like a quick little sketch of it. I'm going to figure out, first off, well, it looks like it is taller than it is wide. And this would be, let's see, this is 10 wide, or 10 tall. And then it is 6 wide. So 10 tall, 6 wide. And I'm doing that just by looking at these numbers. From 2 to negative 8 is 10, that's 10 this way. From negative 3 to negative 9 is 6, so it's 6 this way. So that tells me that the A is half of that, 5, and the B is half of 6, which is 3. And since it's a vertical one, the bigger number squared goes with the y, so it'd be 25, and this would be a 9. And then where's the center at? Well, I could do the midpoint of these two vertices or the midpoint of the co-vertices. It really doesn't matter. I'll just pick these two, the midpoint between these two. So midpoint is the average of the x's and the average of the y's. Well, the average of the x's I can see is negative 6, but the average of the y's, I take 2 plus negative 8 and divide by 2. So that'd be negative 3. So my x, I need negative 6, so that'd be plus 6. And then my y, like I said, this is 3, so negative 6, 3, so that'd be a 3 equals 1. So you find your A and your B, and I never need the foci to do this, so I didn't worry about C. The A and the B tells me what numbers to put here. Is it vertical, put the bigger one here. If it's horizontal, put the bigger one with X. and then find the midpoint. That'll tell you where the center of the ellipse is. Okay, and then how circular an ellipse is. This is it's called eccentricity. If anybody takes some sort of science class with studying space, and those how the orbit is, the eccentricity of the orbit. Basically, just how circular it is, and the formula is take c divided by a. The c we've been talking about divided by the a we've been talking about. And here again, c is the same thing as the square root of a squared minus b squared. To refresh on that. But this number for an ellipse is going to range from 0 to 1. Every time you divide it, it's going to be 0 to 1. If it's a 0, it's circular. It's a perfect circle. If it's 1, it's about as stretched as it could possibly be. It's the most stretched out ellipse you've ever seen. So it's going to, most of ours are going to go somewhere between those two. But again, if you get a 0 for an answer, that means you're talking about a circle, not an ellipse anymore. So determine the eccentricity. Well, this is a squared, this is b squared. So if I can find c, remember c is the square root of a squared minus b squared. So it'd be 100 minus 9. So the c on this one is radical 91. That's c. Divide that by a, which would be 10. Because a squared is 100, so a would be 10.954. So that's a pretty stretched out ellipse. So since the bigger numbers with the axis, they'll really stretch out horizontally. Again, if it's closer to 0, it'd be just about circular. If this number is bigger, it'd be a really stretched out vertical one. The eccentricity on this one, again, your c is going to be the square root of 72 minus 54, which is the square root of 18. And then I really just need to know my a. So my a is the square root of 72. I'm going to take the square root of 18 divided by the square root of 72. You just type in the calculator, you get 0.5. Okay, so the eccentricity, not quite as stretched. It is a horizontal one again. It's going to be, more like that, looking more and more like a circle, whereas this one's really stretched out, not so thin. So, or thin, not so tall. So yeah, so that is 3 pages worth of notes there. Hopefully, if you have any questions, hopefully you'll ask.